Now see, let us take LAQs from statistics. This is the important LAQ. Find the normal equation to a straight line using least square method. So first let us write down the normal equation of a straight line. So the normal equation of a straight line is y is equal to a plus bx. This is the normal equation of a straight line. Now to find the curve of best fit of data at a point x I comma yi, where I takes values 1 to n. Now multiplying equation number 1 with x. So what do you get? Xy is equal to ax plus bx square. Now applying summation on both sides. Summation is sigma. So sigma I is equal to 1 to n xi yi is equal to a is a constant. Sigma I is equal to 1 to n xi plus b is a constant. Sigma I is equal to 1 to n xi square. This is equation number 2. Now we will apply summation to first equation. Applying summation to equation number 1. So what do we get? Sigma I is equal to 1 to n yi is equal to a sigma I is equal to 1 to n plus b sigma I is equal to 1 to n xi. So sigma I is equal to 1 to n yi is equal to sigma I is equal to 1 to n. There is nothing over here. So you have 1. So, or you have I. So 1 plus 2 plus, if you add n times, you will get n. So that is na. Okay, if you don't have anything, then it is n. Yeah. Na plus b sigma I is equal to 1 to n xi. Why? Since sigma 1 is equal to n, where I takes values 1 to n is the size of the data. Now let's say this is equation number 3. So from equations 2 and 3, what do you get? Sigma I is equal to 1 to n yi is equal to na plus b sigma I is equal to 1 to n xi. Now again we are multiplying xi on all sides. So sigma I is equal to 1 to n xi yi is equal to a sigma I is equal to 1 to n xi plus b sigma I is equal to 1 to n xi square. So these are the normal equations. Normal equations for the best fit of straight line. Y is equal to a plus bx. Now solving equation number 2 and 3, we get values of a and b. So solving 2 and 3, we get values of a and b. Now if you substitute the values of a and b in equation number 1, then you get the line of best fit. Now take the next long answer. Obtain the normal equations for fitting of parabolic equation or quadratic curve Whether they ask parabolic equation or quadratic curve, we follow the same method. So first let us write normal equations. Normal equations for fitting of parabolic equation. So what is the equation of parabola? Equation of parabola is y is equal to a plus bx plus cx square. Also, this is an equation of a quadratic curve. Now let equation number 1 passes through the points. Let's say x1, y1, x2, y2, so on up to xn, yn. Therefore, yi is equal to a plus bxi plus cxi square. So we are substituting in the place of x and y, we are substituting xi, yi. That is, first we are substituting x1, y1, then x2, y2, then so on up to xn, yn. So this is equation number 2, where I takes values 1 to n. 1, 2, so on up to n. Now let us say EI be the error. EI be the error found between the expected and the observed values. Expected and the observed values of y is equal to yi. That is, EI is equal to yi minus a plus bxi plus cxi square. Here I takes values 1 to n. So therefore, sum of the squares of these errors is E is equal to sigma I is equal to 1 to n EI square. That is equal to sigma I is equal to 1 to n yi minus a minus bxi minus cxi square whole square. Now to find minimum E, dou E by dou A is equal to 0. Dou is partial differentiation. Dou E by dou B is equal to 0. Dou E by dou C is equal to 0. Therefore, normal equations are sigma yi is equal to Na plus B sigma xi plus C sigma xi square. This is from equation number 2. Okay. So now we are multiplying xi on with each term. So sigma xi yi is equal to a sigma xi plus b sigma xi square plus c sigma xi cube. Now we are multiplying, once again we are multiplying xi with each term. So xi will become xi square yi is equal to a sigma xi square plus b sigma xi cube plus c sigma xi power 4. So if we generalize the above equations, what do we get? Sigma y is equal to Na plus b sigma x plus c sigma x square. So sigma xy is equal to a sigma x plus b sigma x square plus c sigma x cube. Now again if I multiply one more x square y is equal to a sigma x square plus b sigma x cube plus c sigma x power 4. Therefore, solving the above normal equations, we get values of a, b and c. Now this values of a, b and c are substituted in equation number 1 to obtain the parabola of best fit. Now take the next LAQ. Obtain the normal equations for fitting of power curve. Y is equal to ax power b. So for a set of n points, the power curve is y is equal to ax power b. This is equation number 1. Now taking log on both sides. So if you take log on both sides, we get log y is equal to log ax power b. So that is, now we know that log AB is log A plus log B. So that is log A plus log x power B. And also we know that log A power M is M log A. So we can write this as B log x. This is log Y. Now substituting U is equal to log Y, V is equal to log x, and A is equal to log A. So therefore we get U is equal to A plus BV. So this is a linear equation. This is a linear equation in U and V. So what is the normal equation? Normal equation for estimating A and B are, we use summation here. So sigma U is equal to NA plus B sigma V. And sigma UV is equal to A sigma U plus B sigma V square. So we are multiplying V on all sides. So these equations can be solved for A and B, and we get small a is equal to antilog of A. If you find antilog of A, you get small a. Now with these values of A and B, so obtained equation number 1 is the curve of best fit to the set of n points.